Schrodinger model of the atom, it also recognizes that electrons can be in these energy levels, okay? But it also recognized this idea of, you'll see it kind of a fuzz, like a dot, 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 dot. So there is a kind of a region of space, for instance, we expect to find these two electrons. But I'm going to show you on the next slide, there's something called Heisenberg's uncertainty principle. And related to very small particles, we can't know exactly where they are. We know kind of the general region that they are. So this little fuzz thing is kind of what we call the electron orbital. So in the center would be the nucleus, and the little pink fuzz is where the electron would be. Okay. And if you go on into chemistry, or you'll see that kind of the electron cloud, it's not always spherical. And I just think that is so cool. I mean, I haven't dived into how they know what they know, but I've read enough books that it's true. So we can have these spherical orbitals, which is kind of what we usually think of electrons. We can also have these dumbbell-shaped orbitals. These are electron clouds where the orbital is found here or here. Excuse me, the electron is found here or here, but that center is the nucleus. Not there, not there, not there. And then we can kind of take it up a notch. So these are what we call electron orbitals, the spatial region where you expect to find the electron. And then also associated with that spatial region would be a certain amount of energy. So I have a video to kind of show you what Heisenberg's uncertainty principle is all about. But with regard to chemistry, this is what, and it applies to things other than just chemistry. It says we can predict a general region of space, but we cannot know both the location and the amount of energy an electron has. And I've heard it described this way, and this isn't the way the video is going to do it. It's like if you in order to find the space where it is, detect the electron, you have to ping it. And once you ping it, you've altered its energy. So you can't know both. But let's watch this little video, what it says. Okay. So we'll watch this video about Heisenberg's uncertainty principle. But again, it doesn't just apply to electrons. Because some of my slides seem busy right off the bat, and you'll see what I mean. So let's see what we got. I don't know if you guys had any words to fill in here, but it's important to classify things, and this is how we classify matter. Matter is made up of atoms, and matter has mass and occupies space. And matter can either be a pure substance, okay, and if it's a pure substance, we have two options, okay, or matter can be a pure substance, or matter can be a mixture. And these are real common. Well, mixtures are common, is a common term. Okay. Now, what's important is I kind of revealed this thing going back and forth between something that's pure and something that's a mixture. When you think of mixture, you probably think of two more things that are thrown together. Well, you can take a mixture and break it and piece it back out into its individual pure substances by some sort of physical means. A physical means would be like if we had sand and carbon specs, we could take tweezers and separate sand, separate carbon specs. That's a physical way. Another physical way is if we have a sugar water solution and you're like, dude, I just want to get my sugar back. A physical thing, we'll talk about what's the opposite of physical, would be chemical. A physical thing would be just to dry it up. That's a physical thing. Okay. Dry it up, send off the water, you get a residue of sugar. So if you have a pure substance, you either have an element or a compound. And you probably already have a sense of this. And so that's good. It's all of these different things depend on physical science. I have an idea about that. If it's an element, that means that all atoms are just the same. Like if I have a bunch of carbon atoms, it's an element. Okay. If I've combined carbon with hydrogen, somehow I have a compound. I could take my compound and break it back down into my carbon and my hydrogen, okay, by some sort of chemical means, chemical reaction. Right? So chemical reaction is different than a physical process, chemical reactions. We have two options with mixtures. We have one that's well mixed, like a slushy or something, and then, or a shake, and then we have one that's chunky. So those are both mixtures. A heterogeneous mixture, our favorite one would be a pizza. Okay, heterogeneous mixture, you got your crust, you got your sauce, you got your cheese, and it's not uniform throughout. If I had a friend that had a jaw surgery, okay, and they wanted pizza bad enough, I'd stick my pizza in the blender, and then I would get a uniform homogeneous mixture. So periodic tables, I think I'm going to play you this little video. Now, one of the things different about this periodic table and the one I gave you, there's a number of things that are different. But notice that these guys, these ones in this last row down here are not filled in for this one because it's dated. They actually are filled in for the one that I gave you. Notice the periodic table, we picked on carbon, didn't we? Notice we can find a box with C, the letter for carbon, and the number 6, meaning 6 protons. Okay, so all periodic tables should kind of have some similarities to them. Let's play this little video. It's bigger, you get a number, you increase the number of protons in there. So why do we bump up against, actually, why are we limited to 118 protons? And the thing about it is when this periodic table was written, these guys were not, they weren't stable enough, that the scientists had not had them last at least, I don't know, a fraction of a second. Okay, they break back down. As this turns out, I think this is right, notice the RF and HA and SG in that periodic table, they kind of have that weird sort of outline to them. Those are actually all man-made elements. Beginning actually down here, these are man-made. Okay, we had to synthesize them. It's not to say that the stars didn't make them, but they don't last very long. Their half-life is short enough that they have broken back down, even if the stars did make them. So we have to make it for ourselves. Sometimes I wonder, it's like, so you create this, you create something like plutonium. It's been in the news years ago about, actually it's dangerous. It's a good spy thing. In fact, you can kill people with it, okay, in small doses. But like, why create it? What's good with these things? And I like the video because it kind of shows you objects that have these elements in them. So it's all pretty darn exciting. And that this last row, we're going to actually call these rows are going to be what we call periods. This last period on the periodic table I gave you, that's like period 7. When they completed period 7 with the elements, like woohoo! Okay. So, I don't know, maybe it's just me, but I just think it's pretty cool. So 118 exist. 118 different elements exist with different numbers of protons in their nuclei in their center. And 98 are naturally occurring. Of these elements, by far, most of them are solids. I think on this periodic table where you see the red ones are actually gases. Okay, the red ones are gases. There should be 2 liquids. We have bromine as a liquid, and the blue ones are liquids. So we have bromine and mercury. Thermometers used to have, in order for your thermometer to go up to tell you what the temperature is, liquid thermometers, it used to be that silvery cool look of mercury. I personally have played with mercury when I was young. Not anymore. Now they use some sort of alcohol. Most of them are solids. One of the things that I want you to be able to do in this class is, do you see the periodic table though? That's why these things want to start to come off your periodic table. You guys, I call it the JAG. There's a JAG up here, it's in red. The JAG on your periodic table is in black. And that's an important way to chunk up the periodic table. So here's the deal. You see the word metals and non-metals. The way this works is, I don't know, this periodic table is not going to do it for you. I'm not sure if I was y'all how I would mark it up. But somehow you want to mark that these guys are metals, okay? And these guys are non-metals. Somehow do that. So this little small triangle are non-metals, and these guys to this side of the JAG are metals. So that would include these guys down here. So she's kind of emphasizing the JAG. And yeah, maybe if you just even did a non-metals and metals, kind of once you mark the JAG. So, like, you already have it thought. When you think of a metal, you kind of think of shiny, and you're right, metals are generally shiny. The thing about metals is we can kind of pound them, we can kind of make them into our pots and our pans. Our non-metals, you cannot. You try to pound it, it just falls apart. Okay? So that's one distinction. This last thing that I put up here, this last bullet, they increase by the number of protons. And you might want to underline or whatever the word atomic number. Somehow you need to link the phrase or the term atomic number with the number of protons. And again, we've talked about how stars have nuclear fusion going on in their core, and it's the centers of the stars with these high pressures and temperatures that can go ahead and kind of make heavier and heavier atoms. Okay. What else we got? Okay, the periodic table. If something is periodic, it like comes back around again. Actually, the days of the week are periodic. And I think my slide kind of does that. Let me put this whole thing up. That whole thing up. So if something's periodic, it comes back around again. So here's a calendar. Here are the days of the week. I'm going to start with Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay? So in general, I can start my week, and you probably can too, thinking, all right, so technology is not going to work today. Monday, no one wants to be here. Okay? Tuesdays, we all have something to do. Kind of things change up a little bit. Wednesday's hump day. Thursday's the day before Friday, and Friday is, Friday's Friday. Okay, Saturday's the weekend. Okay, Sunday is kind of a transition day. Okay, kind of get back to the grind, and then we start it all over again. Now, not that all of these Fridays would be the same, but they have some similar characteristics. And so when it's Mendeleev Dmitri is the guy's name, the scientist's name, when he came to actually assemble these different elements, he assembled them with that in mind. Okay, so the numbers are the numbers of protons, and those would be like the day of the month. Okay, but it cycles back around again. So we have this very important sort of situation where these are all, I'm going to run out of days and weeks, but these are all Sundays, okay, these are all Mondays, and actually these guys, we're going to talk about them, they're not as, I don't know, they don't play as well as the others. So this could be Tuesdays, Wednesdays, Thursdays, Fridays, Saturdays, Sundays. Okay. So, and the other word, I don't know if you want to add this to your thing too. Just trying to think ahead. I know it's going to be a while before you have your exam, but I have two terms. One term is called the group. So if like over here, if you want to put like a down arrow and say group, each of these are groups. Okay, each of these are groups.
Like with the numbers up top of this?
So yeah, that's actually the group number. But any column is a group. Any column is a group. So I would say, if I'm skipping over here to these guys, I would say, like you're saying, David, I would say group 7A, I have fluorine, chlorine, bromine, iodine, and acetylene. Those are all in group 7A. Along those lines, what I probably would do, and I mentioned it, the word period a little bit, probably over here to the side, I would draw an arrow, and I would say these are periods. The horizontal, like this would be a week. This is periods, and actually on this periodic table and the one I gave you, at the beginning it says what period it is. So this is period 5, okay, this is period 4, okay, period 3 is kind of segmented, so period 3 starts here, it skips these, there's nothing here, and then period 3 continues here. Okay, so periods are kind of the horizontal rows. So a period would be like the week you're experiencing, and a column would be like the day of the week, and they all have some lyrics like that. And as chemists then actually look for, like if they have a chemical reaction, they're like, well, I know it works with oxygen. Okay, I know it works with oxygen. What else would it work with? And I can't remember what, there's all sorts of silly science fiction movies out there, just kind of horny. There's one, it's Evolution, I think, the sci-fi movie called Evolution. And instead of an oxygen-based life form, okay, this is near the end of the movie, they find out it's a selenium-based life form. And there's actually some chemical basis for that, because you would think oxygen and selenium would behave similarly. So, okay, so do you need this one right here? It says, for example, beryllium, magnesium, calcium, strontium, barium, and radium have similar properties. One of the things, and I think it's maybe on the slide that I get to, I tell you that for a handful of elements, I want you to be able to match up the symbol. The symbol is just like the cap of a letter, or letters. The symbol with the name. So I'm going to tell you which ones. And you could even just add this to your cheat sheet. So you could, it's not really a cheat sheet, but you could start your cheat sheet as you go along if you want. It's not really a cheat sheet, but I think you can take your test. Okay. So like I said, this kind of emphasizes these are groups, okay? And notice that actually the groups sometimes have more than one designation, which that's just the way it is. Kind of the newer convention, not new, kind of the newer convention are the 1 through 18. But to me, those aren't as descriptive as you see the 1A, 2A. This is 3B, 4B, 5B, 6B, 7B, 8B, 1B, 2B, and then the 3A through 8A. I like the A, B, A. I like those designations more. And actually, just recently, I finally put them on this periodic table. You can see the 1 through 18 just fine. You can also see my handwritten 1A, 2A, and these would be the groups. So, and these are the periods, and I kind of told you to mark somehow know what we're talking about here. Make good vocabulary words, right? For your unit 2 exam. And this is not every time a unit 2 exam. We just took a unit, or this is the unit 3 exam. We just took our unit 2 exam. Yeah. I think I have a slide coming up, but do you see where, and the video on elements talked about this, do you see where at atomic number 57 protons, then we have to actually, in order to get 58 protons, we have to come down here, and that'll go 58 through 71 protons, or atomic number 58 through 71, and then we have atomic number 72 up here. So these guys are actually kind of inserted here.
Why is it like jumped out?
Periodic tables, see, I've heard it described this way. If I was going to show, like, for instance, the 58 through 71, I kind of have to make it three-dimensional. One way to make it, to show them on a periodic table, to be counterable. And another way, I guess, bottom line, I hope we'll get into this in this course, but it has to do with electrons. It has to do with the type of electrons that are being added here.
I used to know why they just put it in.
Yeah. I guess, yeah, you're right. So, like, why don't they just go ahead and split it here? And then I think part of it is, don't you think logistics, too? The periodic table gets too long. Too wide. Periodic table gets too wide. But there might be periodic tables out there that do that. They go ahead and make the break and scoot everything over. So I'll have to see if I can find it again. And we have a similar thing with this one. Now, you guys have the period markings here on the black and white one, it's not on that one. But for instance, can you see where the 58 through 71, that they would be in period 6? Does that make sense to you? They'd be period 6. Yeah. And then these thorium through Mauritium, I think, that actually would be period 7. So, valid questions. So chunking up the periodic table of elements, there are other ways to chunk it up beyond just the JAG. So I say know these group names. Oh, I'm like, I can't see where the group names are. Here's another thing to add to your periodic table. So it probably won't be at the bottom, but at the top, for instance, at the top of 1A, I would write the word, and I'm not telling you what to do or why, but these guys are what we collectively call alkali metals, okay? And then 2A are alkaline earth metals. So I would denote that somewhere. So that's 1A, 2A. And then we jump over to 7A, and those are called halogens. You probably heard halogen lights, okay? So if we kind of look at the elements in 7A, you're looking at fluorine, chlorine, bromine, iodine, astatine. And then that last one there is 8A. 8A actually has 3 names: noble gases, inert gases, and rare gases. So I'll add those. I would mark your periodic table. Noble gases, inert gases, and rare gases. Those are all 8A. And you might be, well, Mrs. Snipes, which one will you call it? And I don't know. I might call it any of them. So know those. We use the word representative for the main group elements. I'm going to add to my slide here. The main group elements are the ones that have A in them. Main group elements. Main group elements, representative elements. They're green up here. You okay with that? They're green. I gotta be careful. Not everybody can see that. Can you go back? And every time I teach them, like, oh yeah, that's how we should do it. Because now this slide, if you want to, again, I'm not telling you what to do, but if you want to, you can take this, which you can take your test with you, and you can find all of these elements and you can write their names in it. So, for instance, I want you to be able to match up the name and the symbol with elements 1 through 20. So that means 1 through 20, and I don't know if you want to, how good your writing is, and you can kind of write it on the side there. But 1 through 20, you need to be able to match up the symbol with name. Now, some of you already know, like, what's the symbol for nitrogen? Starts with the letter N. Nitrogen is the symbol N. Yeah. Some of them make sense. So you guys, anybody know the symbol for iron?
IR.
No, it's not IR. It's like Latin or something. It starts with the letter F. It is Fe. Yeah. And so that's one where, and if I find Fe, iron is atomic number 26, and then what this slide does is say, now, does Mrs. Snipes need me to know 26? And if I find it, actually, the answer is yes. Because 26 is between 24 and 30. You know what I'm saying? So, know those symbols of those things. You guys got spring break coming up. You can work on it. You guys not this slide? Oh, drat. I sure don't see you guys. I think the next topic or whatever, I kind of want to start with this next slide about elements with similar properties in a group. I want to start with that on Wednesday. So we're going to have just a few minutes, I believe. I'll get used to it. Or maybe. Snow days. It'd be nice. And then Thursday's your lab. I think I might have already mentioned. I do have a lab in mind, and this time we won't be doing like chemicals and all that. So you won't need goggles. And I've got all sorts of goggles, so don't go out and buy goggles unless you want to. But
So putting like calculator.
so that's a let's see, calculator. You won't need it for Thursday's lab, but at some point you might want a calculator. Yeah. Exactly. So Thursday we might check into lab, getting ready for Thursday after spring break.